Hello, Year 11. Here is Dr. Tolchinova helping you with your homework on indices. Before we'll start looking through these indices laws, I would like just for you to remind what those all indices mean, alright? So, for example, the first index form of a particular number, you see 7 to the power of 3, I would like you just to remember it is not in any ways 21. Alright, what 7 to the power of 3 means is 7 times 7 and times 7. This little 3 here serves one only purpose. It is index, alright? It indicates how many times 7 has to be multiplied by itself 3 times. It is like traffic light saying like multiply me 3 times. I'm 7, multiply me 3 times. Here is 7 to the power of 10. 10 is the index, alright? It tells you how many times 7 has to be multiplied by itself. 7 is called base, alright? Base, alright? It is main number. That's all about 7. 3 is just signal how many times to multiply base by itself. Okay, that's why you see when you see 7 to the power of 3 and 7 to the power of 10, it means you multiply 7 by itself 3 times, and you also multiply 7 by itself 10 times. So what you have here is just 7 multiplied by itself 13 times altogether, right? So that's why we say when you multiply powers, right, these numbers, everything what you have to do is to add indices, because at the end you actually multiply 7 by itself 13 times. That's why we added indices, alright? Okay, different a little bit story when we divide indices. Okay, so what we have here, 7 to the power of 15, and I would write them as a fraction, like 7 over 15 to the power of 15 divided by 7 to the power of 9. So as you know from definition what indices are, we'll have 7 multiplied by itself, you know how many times? 15 times, right? 15 times. Okay, 15 times, so we'll have 15 sevens, 15 times. Alright, and here we have 7 multiplied by itself 9 times. Okay, 9 times. So what we will do is we will be dividing fraction top and bottom by the same number. So we'll say obviously the same number is 7, right? So we'll be dividing by 7. 7 divided by 7 is 1. 7 divided by 7 is 1. How many times we will be able to divide? 9 times, I think, right? And all 7s here, all 9 7s will go away here and there. 9 times will go away and 6 will be left. 15 minus 9 is 6, isn't it? So, and here we'll have just 1 times 1 times 1 times 1, 9 times, so which is just 1. So that's why we're saying when we divide powers, alright? When we divide powers, we subtract the indices. So it is 7 to the power of 6. Alright? So now what we've got here, 7 to the power of 12 divided by this. 7 written without any index can be written as 7 to the power 1. Because if you just have the number, right? And so you repeat it by itself once. That's what it is, right? So what do? We add indices when we multiply 7 to the power of 5. And what do we do now? When we divide indices, we subtract them, right? When we divide powers, we subtract the indices. So we have 7 to the power of 12 minus 5, which is 7, alright? Please remember it's not 49. It's big, huge number. You can check. Alright? So here what we have, 7 to the power of 5, and then all of this to the power of 4. Just think about this, right? What you've got. So you've got 7 to the power of 5 inside, alright, which is 7 times 7 times 7 times 7 times 7, 5 times, alright, to the power of 4. So what does it mean? We have to have 4 bunches of 7 times 7, 7, 7 multiplied by itself 5 times, alright? So how many all 7s altogether we'll have? We'll have 5 here, 5 here, 5 5 sevens here, 5 sevens here, 5 sevens here, and 5 sevens there. Altogether we'll have 5, 5, 5, 5. So altogether we have 27s, right? So 27s indeed. So when we say if we have power of another power, in fact what you have to do is to multiply indices by each other. So we'll get 7 to the power of 20. But it's okay if you don't remember these rules, but please try to think about, right, what they mean, what actually indices are, right? Remember just the definition and try to imply them every time. So you should understand that when you have to add them, when you have to multiply them. If you don't remember, just simply start writing what 7 to the power of 4 means. 7 times 7 times 7 times 7 times 7, right? 5 times. And then what that means, all of this multiplied by itself 4 times, so you have 7s written 20 times, which is 7 to the power of 20. That's it. Okay, so let's do now the second question. Write as a power of 5. So they don't want you to actually to say the answer to work out what that is. They will be happy if you will give it the answer as a power of 5. We have multiplication here, so we add the indices. We add 8 and 4, we get in 12. Done. Alright, here it's a little bit like we need to do it step by step. So on top we multiply powers of 5, so we're getting 5 to the power of 13. Why 13? Because this 5 can be written as 5 to the power of 1, right? And so we add in the indices 12 plus 1 is 13 over 5 to the power of 4 times 5 to the power of 3 is 5 to the power of 7. What do we need to do? We need to subtract the indices, right? 13 minus 7 is 6. That's it. Done. Here we have power of another power, so we'll get 5 to the power of 6. Done. Alright, now we need to solve this equation. We have here powers of 6. Alright, when we multiply them we are getting 6 to the power of 11, because 8 plus 3 is 11, and here we have 6 to the power of 5 plus x, right, because we also add the indices. But you see they're saying we have this number equal to this number. The base is the same, so the indices have to be the same. So 11 should be equal 5 plus x if we want these numbers to be equal, right? So x will be then 11 minus 5, which is 6. Done. Done. Alright. Okay, now we need to simplify 4 to the power of 0. If you know that 4 to the power of 0 is always 1, right? And I can show you why it is a 1, alright? So look, imagine we have 4, say, to the power of 2, and we divide it by 4 to the, say, power 2, alright? Because we divided the same number by itself, surely it is 1, right? Because the number is the same. But we know that if we divide the powers, right, and the base is the same, so we subtract the indices. So 2 minus 2 is 0, isn't it? What's that really important that here I have chosen 2 as the index? Check if I will choose 5 and 5 here. Will make it any difference? It still will be 1, right? Because we're still dividing the same number by itself. It's on the right side, I still will have 4 to the power of 0 because I still subtracting the same index from itself, right? So it seems like for any number actually, and yes, the number 4 is also not quite special. I can choose any number at all, say 7 to the power of 5 divided by 7 to the power of 5. I will get 7 to the power of 0 because 5 minus 5 is 0, and also I will get that it is 1 because I'm dividing the same number by itself, right? And that's how I'm getting that any number to the power of 0 is 1. Alright? Now final question. Okay, here we have mixture of different bases multiplied by each other. Alright, they're saying write this number as a single power of 3. Alright, how? I see the bases are different, but each base can be written as a power of 3. How? 9 is actually, remember what 9 is. 9 is 3 times 3, right? Which is 3 to the power of 2. And which is 27? 27 is 3 times 9, or 3 times 3 times 3, or 3 to the power of 3, right? So I can change now 9 here to 3 to the power of 2, to the power of 2. Alright, and all of that is to the power of 3 as they wanted. 9 to the power of 3, 9 is 3 to the power of 2 to the power of 3, right? 27 in the index form, 27 is 3 to the power of 3. Alright, so I will replace my 27 here, I will replace it with 3 to the power of 3, right? And 27 was to the power of 2, so I have it. What do we do when we have power of another power? We multiply them. So we multiply 3 by 2, we are getting 6. We multiply 3 by 2, we are getting 6. So what do we do when we multiply indices and the bases are the same? We just add the indices, so we are getting 3 to the power of 12. Done and dusted. We can go to the next question. Alright, here they're saying write all of this as a single power of 2. Okay, again, it's so much easier to deal with, all questions when they have the same base as it was in question with 7s or with question in 5s. So here we are going to achieve the same, alright? So what we are going to do is we are going to write every number here, 8, 4, with the base 2. So what do we know about 8? We know that 8 is 2 times 2 times 2. You can check. 2 times 2 is 4. 4 times 2 is 8. So that is 2 to the power of 3, isn't it? And what is 4? 4 is 2 times 2, which is 2 to the power of 2, right? Okay, now let's go back to our question and let's replace all 8 and 4 with what they are in the index form with the base of 2. So I will replace 8 with 2 to the power of 3. And that was to the power of 6, as you can see here, 6, right? And then we're dividing that by 4, which is 2 to the power of 2. Alright, to the power of 3. And then we have to multiply it by 2 to the power of 5. So what do we do now? We clear up all these indices, right? 3 times 6 is 18. 2 to the power of 18. Divide by 2 to the power of 6. Multiply by 2 to the power of 5. Alright? What do we do when we divide indices? We subtract, alright? We divide powers, we subtract the indices. So what do? We subtract 6 from 18. We are getting 12, right? 12. And then, so we'll get 2 to the power of 12 times 2 to the power of 5. Done, okay? And so what do we do now? We multiply the indices, right? So what we do? We add 12 and 5, so which is 17. So that is 2 to the power of 17. Done. End of homework. Thank you for watching.